cryptographic hash function is a mathematical formula that helps you convert a given value to another string value that is irreversible. The resulting value after hashing is smaller compared to the data that passed through the function. Often these strings have fixed length. As you can see here on the screen, the input varies from fox to the red fox jumps over the blue dog. We are using the same cryptographic hash function, and the resulting hash or message digest is of the same length. Even if we change one character, like between this input here, the red fox jumps over the blue dog, and between this input here where we remove the V, the resulting value is a totally different hash. So in other words, hashes are fingerprints of some data, and it's about random looking characters that uniquely identify the data in question. What can we hash? If you look here at the right picture, you can hash anything. You can hash text, sentence, a password, you can hash a file, you can hash an MP3 file, you can hash any kind of file like ISO files, anything. We use hashes for three purposes, so mainly to verify files. So software creators often take a file download and run it through a hash function, and then they on their official site the hash and the file to download. So in order for you to verify that you've downloaded the right file, it hasn't been compromised or infected with malware, you just download the file and generate its hash and compare the hashes that are found on the website and the hashes that you generate, and if these match, then you have downloaded the right file. Let's take a simple example here. If you open PowerShell and let's go here to the root C. Suppose that you downloaded this file here and you just want to get the hash of this file in order to know that this file has not been compromised. You can do this by running this command, get file hash, and then the name of the file, and here you go. You will get this hash. Now you just have to compare it with the hash found on the website that you've downloaded the file from, and if there is a match, then this is the original file. The other purpose is for password storage. So there are two ways passwords are typically stored on a computer website. The first is in plain text, and if a crook steals a plain text database of passwords, they will be able to see the passwords in clear text, and this is so wrong. So the best way to store passwords is to hash them first. When you first create a password on a secure system, it hashes the password before storing it. So it does not store your actual password in the database. It stores the hash of the password and forgets what you actually typed. The next time you type in your password, it hashes what you typed in and compare the hash that it generated with the hash that is stored in the database, and if there is a match, you will be granted an access. This is so valuable because if the hashes or if the hash database is stolen, it cannot be read by the bad guys, supposedly. Instead of seeing a list of passwords, they will see a list of hashes that can be useless. The third type of usage is database searching. So hashing can speed up the process of searching through a database. Say that we're storing a long list of names in a table, and we need to find if a certain name is in that list. Well, the computer can do a search for the name, of course, but that might be a long process because it has to match a large string of characters. So we can significantly shorten that time by creating a hash for every name on the list, and as long as the hash is shorter than the average name length, then the search will be faster and easier. Here are the list of mostly used hashes. We have SHA1, 256, 512, MD4, MD5, LM and NTLM. Each produce a different length of hashes and characters, and here are some of the examples. It's good to note that difference between encryption and hashing. Encryption is a two-way function. Data is encrypted with the purpose of being decrypted at a later time, and this is the only good way to store and move data in a secure fashion. Meanwhile, hashing is never meant to be reversed. It's a one-way thing. So it's not meant to be a secure way to store or move data, but it's a purely used as an easy way to compare data or to compare blocks of data. As you might have realized, there is a problem with hashing since they produce a fixed length value, and we have a finite number of hashes for each type of algorithm, which makes collisions possible. So a collision is when two different data or inputs of data produce the same exact hash. This is rare, but it happens. So naturally, the longer the hash value, the less likely a collision will happen.